Modern life is built on a constant, invisible flow of data, driving everything from the smartphone in your pocket to the server racks training the next generation of artificial intelligence. Beneath that data is a physical foundation, the advanced semiconductor. To achieve these speeds, transistors are packed into grids so dense they push the limits of material science. Production for these chips is dominated by household names like TSMC, Samsung, and Intel. Their massive, multi-billion-dollar factories across Asia and America suggest a robust and highly diversified global network. But that diversity is an illusion. Despite their massive scale, every one of these giants is tethered to a single high-tech umbilical cord. Trace the manufacturing equipment back to its source, and you find a Dutch company named ASML. While their name rarely appears in consumer headlines, the machinery of modern civilization cannot be built without their hardware. This raises a question for anyone tracking the global economy. How did a single, relatively quiet company secure a total monopoly over the most complex manufacturing process on the planet? In 1984, the answer wasn't obvious. ASML was a struggling joint venture between Philips and ASM, operating out of a cramped, leaky shed next to a corporate office in the Netherlands. Their specialty was photolithography, the process of using light to print circuit patterns onto silicon. Looking at these manual assembly lines, you can see how different the scale of precision was in the early 80s. At the time, they were a rounding error compared to Japanese giants like Nikon and Canon, who controlled the market and possessed far deeper pockets. ASML spent years on the verge of collapse. Their current dominance wasn't an inevitability, it was the result of surviving a decade where they were consistently outmatched and underfunded. The 1995 IPO changed the math. This influx of capital from the public markets gave ASML the runway it needed to stop worrying about monthly survival. Rather than trying to build the cheapest machines to compete with the Japanese leaders, the company changed its trajectory. They committed every cent of their new funding to a high-risk bet on a technology that many physicists believed was impossible to commercialize. That technology is extreme ultraviolet lithography, or EUV. This diagram shows why the wavelength of light matters. While standard light is too blunt to draw modern circuits, EUV waves are short enough to etch patterns at a nanometer scale. To harness that light, ASML built a machine costing $150 million, requiring thousands of specialized components from a global network of suppliers. These cleanrooms are the only places on Earth where this precision can be achieved. Each machine is so complex that even with the blueprints, other companies haven't been able to replicate the results. ASML is a monopoly because they are the only entity that has solved the engineering challenge of mass-producing EUV systems. Today, ASML is the singular bottleneck for the global semiconductor industry. While the chain involves thousands of suppliers for optics and chemicals, every advanced logic chip on Earth is eventually defined by the light from an ASML source. This technical monopoly makes ASML a strategic instrument for any government that can influence its exports. This map illustrates why the company is at the center of US-China tensions. Export restrictions are now used as a tool of statecraft, legally preventing the most advanced machines from crossing certain borders. Limiting ASML shipments is the most direct way to cap a rival nation's ability to develop high-end AI or sophisticated radar and missile systems. A company that began as a joint venture in a shed now regulates the technical ceiling of every major economy. In a global competition for computing dominance, the winner is often decided by whose factory gets the next delivery from the Netherlands.